Hi guys, so today we'll be solving Leetcode problem sliding puzzle. So we are given a 2 multiply 3 board. There are 5 types labeled from 1 to 5 and an empty square represented by 0. So a move consists of choosing 0 and a 4 directionally adjacent number and swapping it. So if the state of the board is solved if and only if the board is 1, 2, 3, 4, 5, 0. So we are given the puzzle board return at the least number of moves required so that the state of the board is solved. So if it is impossible for the state of the board to be solved, then return -1. So as you can see here, example 1, we can solve the board if we move this tile with this tile, right? Because this tile is a 0 and we swap it with the tile on the right side of it. Now we have the desired state, hence the board is complete. Here is an example where we cannot solve the board, and here with the first move we can do 4, 1, 2, 5, 0, 3. Okay, so we move 5 from here to here, right? And at move 2, 0, 1, 2, we move 0, 4 from here to here, and vice versa. And at move 5 we get the desired state, which is 1, 2, 3, 4, 5, 0, right? At first I thought that this can be solved using some greedy algorithm, or if I know how to play the game in real life I can apply it to here. But you can take a look at the constraint, it is pretty low. Probably we can do something like backtracking, recursive, or maybe even breadth-first search, right? We treat each of these states as a node. We treat each of the move, right, as an edge, right? And then we will do a breadth-first search up until a point where we get the desired result, the desired node here, right? And at that moment we will return the current level, right? The move that we are in, right? So the logic is fairly simple. If you have done any exercise using breadth-first search, basically we will need to initialize a cube, right? And a visited set, or I would like to call it scene. Okay, here is the tricky part. Since a set in Python doesn't accept a list as an input, we will need to somehow find a way to actually recognize this board state, right? And the first thing coming to my mind is that we can actually flatten it. What do I mean by that? We can actually, instead of using a list, we will use a tuple, and then instead of using a 2D list, we can actually flatten it to be a 1D list. 1, 2, 3, 4, 0, 5, and then we can transform it into a tuple, right? And using that way we can actually add it into our set. And here's how the flatten board function works. which is a tuple. And here how you insert a new element into a tuple. Right. Okay, so now we have we need to initialize a variable called current level, which is initially set to 0, means we haven't done any move, right? So yq, so the board and is going to be so basically the idea for breadth search here is that for each level, right, for each move, right, we will explore every possibilities, right? We'll explore every possibilities, and then if we find a possibilities that will lead us into the result state, then okay, so now that's the current level is actually the minimum number of moves required so that the state of the burst is solved, right? We explore every possibilities, right? And if we see a state that is actually in a scene set, a visited set, right, we don't need to explore it anymore. Why? Because if it can lead us to a result state, maybe it's already lead us into the result state in the past, not up until now, right? Imagine breadth search as pouring water into a sewer, right? The water will come into the place that has the minimum distance, right? So basically that's what's happened here. We treat every of these state of the board as a node, and then every move means every move consists from swapping this 0 element to a 4-directional adjacent number as an edge, and that edge will lead us into a new node, right? Okay. Our current board is q.pop left, means we pop anything that comes in the soonest, right? The earliest. Okay, so if I'm going to find is equal to result, which is return current level, right? Then else we'll keep exploring new possibilities, right? For R in range 2, if current board RC is 0 for DRDC in right? Okay, so now we have found out the type where it is 0, right? So now we will have to create a copy of the current board. I will do that by using list slicing. So the tricky part here is that basically you can do this, right? Okay, so you can copy a board by using the assign operator, right? You can do this, but remember that list in Python is actually mutable object, right? So if I create a new list by using an equal sign to the current board, every change that I apply to this list will be applied to this list, right? And we don't want to do that. We want this list to be on its own, mean that it has no connection to this list, and we can do that by using list slicing. Let me show you. What are we going to do next? For DR is seeing this. Okay, create a new list. If is inbound, right? What we are going to do is that we are going to set right. This is what we are going to do. We are going to make the new R and new C into 0. And then we make the R and C into wait a minute. And RC to 0. So swapping this guy, so this guy R and C. This is RC, this is NRNC. NRNC will be set into 0, that's correct, since we move this guy downward. So the copy board NRNC, so current board NRC, right? Okay, so we have successfully created a copy board. This will be the new state that we will be pushing into our queue and our scene set if it's not already visit. Okay, so we will check it if flatten board is going to sell a flatten board copy board. Actually going to do is that we want to queue append copy board. Then we're going to say scene add. Okay, so that's it. And then here at the end of the loop, we're actually going to increment our level by 1. And for the case where we cannot solve the puzzle, we just return -1. Right? That's it. Okay, so that works. Submit it. Okay, so as you can see, it's pretty efficient. Okay, so about the time complexity of this solution, or maybe this task overall, is, so imagine we have 6 ties, right? How many number of states can we possibilities can we possible makes, right? This is actually 6. Right? And equal to 7,200. Okay. 720. So that's the number of states that at most we will have to visit, right? So it's actually going to be O of 720, or equal to 01, right? And about time complexity, and also for each of these states we will visit 4 edge, right? 4 edge that is actually adjacent to the 0 ties in the state. Yeah, this is actually all of number of state. Yeah, it's also 01. Okay, so that's it. That's it for today, and I hope you guys understand the solution, and thanks you guys for watching. We'll see you guys in next video.